Because I just started recording. Say it again.
CPCTC.
There we go. Very good. Okay. So this is how we're going to use this. Okay. So up to now, you've been just proving triangles are congruent. Well, now you're going to start proving that parts are congruent, not triangles. So what you do when you have to do that is you prove that the triangles are congruent. And if the triangles are congruent, then each of the corresponding parts are congruent. And so you say by CPCTC. Just watch. Just follow me. Explain how you can prove that angle A is congruent to angle C. Oh, it's not a triangle this time. It's a part of it. But I've got to prove that the triangles are congruent first. So let's look at this. I have this and this and this and this. What else do I have here? So the triangles are congruent by what? So I'm going to abbreviate. I don't want you to abbreviate, but for the sake of time, I'm going to abbreviate here. Triangle is congruent to triangle by SSS. Now I'm not done.
Would you still have to say like
Now I have to say this. This is not a proof. This is just kind of stating what we would do. Now I'm going to say, okay, if that's true, angle A is congruent to angle C because they're in the same spot, corresponding, correct? By, what is it? CTC. So if I prove they're congruent, the triangles, I can say the corresponding parts are by CPCTC. That's what we're going to do, the next three proofs. That's it. Okay. So, again, you prove the triangles are congruent. Then we'll prove that FK is congruent to HK. Okay, so let's take a look at what we got here. We were told that GK bisects FGH and FKH. What does that do for me?
That the sides are equal. Congruent.
Not the sides.
The angle.
The angles. If this bisects this angle, then that's congruent to that, correct? And it bisects this angle, so this is congruent to that. And then we know that this is congruent to itself, correct?
Yeah.
So if I look at just one of the triangles, I can do angle, side, angle. Yes.
Isn't FG equal to GH because bisects does?
Yeah, that's what that little thing is. Yeah. Yeah. Okay? So I have to prove ASA. So I'm going to start by writing down the given. Given that GK bisects angle FGH and angle FKH. I can say angle, I'm going to start over here, FGK is congruent to angle HGK and angle FKG is congruent to angle HKG. Why can I say that? No, not CPC, not yet. By definition of bisector. Okay, just to keep myself straight, I know that I've proven the angle and I've proven the angle here. All I have to do is prove the side is congruent to itself. Yeah, so then I would say, okay, then I need to say that GK is congruent to GK by the reflexive property. So there's my side. Now I can say So triangle FKG is congruent to triangle HKG by, what did we say? ASA. So now I'm almost done. I'm going to make my final statement. Now that I've proven the triangles are congruent, I can now say that FK is congruent to HK by what? Yep. By CPCTC. Cool? That was a short one.
Now it's going to be the longest.
It's a bowl.
No, it has more. That doesn't mean that.
Okay. If P is the midpoint of MS, that means that's congruent to that, which they pretty much show us. How wide is the bull's pasture? Okay, so looking at this, I need to prove that these triangles are congruent, so I can say that that pasture is 40 feet, right? So I'm going to prove that they're congruent. So far they told us these angles are congruent, yes? And I know that these are congruent. What else can I say in this picture? Why?
Ooh, the other side is 60.
Why can I say that those are congruent?
Because
Vertical angles. So let's look at one of them. What do I have? I have angle, side, angle. So I'm going to prove angle, side, angle. Angle, side, angle. So let's start with the given. Given that P is the midpoint, I'm going to abbreviate midpoint, of MS, then I can say that MP is congruent to SP by what? Definition of,
vertical angles.
not yet,
For
by midpoint, by definition of midpoint. I'm abbreviating. So there's my side. I did that. Now I've got to do my two angles. Okay, I'm going to do the vertical angles now. Angle MPN is congruent to angle SPR by what definition? Definition of vertical angles. Okay, so there's one of my angles. Now I got to do the other angle. Now be careful. I know the picture shows the box, right? Which tells us they are what? They tell us it's right angles. We have to clarify that that means they're both 90 degrees if we're stating that their measures are congruent. Okay, we're going to say that. So we're just going to start by saying angle M and angle S are given right angles. And then I'm just going to say both 90 degrees by definition of right angles. So angle M is congruent to angle S. And there's my final angle. So I've done angle, side, angle now. You could do it in a different order. It doesn't matter. Just as long as you prove those three things. Now you can make your congruent statement. Then triangle SRP is congruent to triangle MNP by ASA. Almost done? we can then say that, right, so RS is congruent to MN. By what?
C, D, C, T.
Right. So the pasture, the bull's pasture is 40 feet. Isn't that fun?
What?
40 feet wide. Put wide if you want. Can you do that, you think? That's not too bad, right? So let's make it, let's step it up a notch. Okay. So this one here. Angle 1, let's mark what they gave us. We have to prove triangles here. But in the midst of that, we're going to use CPCTC. So angle 1 is congruent to angle 2. I'm going to mark that right there. Angle 3 is congruent to angle 4. I need to prove that these two are congruent. So, let's talk. What's one thing we can do?
Vertical angles.
We can do vertical angles. We know those are congruent.
Yeah, that one. I was thinking the other way.
What else can we do? Linear pairs. Linear pairs. Look at right here and right here. So I'm doing them in different color. So those are congruent because of the definition of linear pairs. Both congruent to the same size angle. All right, so now what? Alexa. Oh.
Just kidding.
Sabina?
Are N Q congruent because all the angles have to add up to
Which one?
and like P, Q, R, and N, M, R.
Not sure that that's a theorem. I've not used that theorem. So I see what you're saying, but there's another way we can go. What do you think, Nicole?
The third angle.
Third angle theorem. We could use
I
that.
thought she said there's not one.
There is, that's right, the third angle theorem.
There is third angle, not third side. Jeez, Julie.
But then you can't really.
But you can't use angle, 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 so it doesn't really help us.
Conical. Okay.
Can't use angle, angle, angle. However, why did they give us 1 and 2?
Because, so then you can figure out the license. I don't know.
Let's draw a picture. Let's draw this. I'm sorry, this is a little bit off. And Q. So here, I know Q, and I'm going to draw this one here. So these are the big triangles right here that I'm drawing. This is M, Q, P. I know that those two are congruent to themselves. Yes?
Yep. I'm good.
We've already decided that N and P are going to be congruent, right? N and P are going to be congruent by linear pair stuff. Okay, I'm getting there. Stay with me. What is another thing I know about these two big triangles?
That they
What about this right here? MQ is congruent to MQ, right? So stay with me. You know I'm going somewhere with this. So we know that these big triangles are congruent by what? Angle, angle, side. Okay, well, hey, well, look at this. If they're congruent, then MN and PQ are congruent, right? By CPCTC?
Yes.
Oh, so that is congruent to that. Do you see it?
Yes. Wait.
Stay with me. MN is congruent to PQ, so this is congruent to... Oh, then look inside our little triangle. What do we have? Angle, angle, side.
That was planned out.
So we have a lot to write. Okay? We're going to start it. Because you guys have a meeting on, we got to start it. It'll take, if we don't, it'll take out, we'll start it, and we'll see where we go. So let's start with the given. Given angle 1 is congruent to angle 2. And angle 3 is congruent to angle 4. Since angle 3 is congruent to angle 4, then I'm going to talk about 5 and 6 right now. Angle 5 is congruent to angle 6 by definition of what? What am I saying? Yeah, of linear pairs. I'll be honest with you, I feel a little shaky about that, but that's okay. I know it's true. I'm just not sure if I should have put more, but that's all right. We'll go with it. They're both congruent to the same angle, so we'll just say definition of linear pairs. Okay, so far I've done an A. Right now I'm working towards proving that these triangles are congruent, because I need that in order to prove the little triangles are congruent. So now I'm going to say MQ is congruent to MQ by what property? There's my side. So again, I'm working on these big ones right now. The last thing we have to state is that that's it. Because we already have 1 and 2 here. We have these here, so we're good. We can now state that those big triangles are congruent. So triangle NMQ is congruent to triangle PQM by AAS. I might have named it wrong. NMQ, PQM. No, I did it right. Oh, let's just finish it. So now that we've done this, we can state these two, right? That's what we need. We need those up there. So we'll state these two. So I can say NM is congruent to PQ by what? CPC2C? The last thing I need to talk about are these. The vertical. We didn't do the vertical yet. Okay? We did 5 and 6, and we've gotten this. Now we have to do the vertical. So that's the last thing we got to do. So angle NRM is congruent to angle PRQ by definition of vertical angles. So I have, for my little one, I have A, I have my side, and I have my A for the little one. So now I'm done. Triangle MNR is congruent to triangle QPR by angle, side. Give yourself a round of applause, man. That was tough. That was tough.